Okay, we are now recording, so we can go ahead and get started. So we didn't have class on Monday, which, again, there's just an unfortunate situation going on that I couldn't avoid. So in lieu of class of Monday, I had asked you guys, make sure you watch, the lecture 23, which was the long division. And then we also had, coming into today, we had the rest of 3.3, which was synthetic division, and then a couple theorems that also fell out, remainder theorem and factor theorem. So if you guys want to start asking questions from either of the homeworks, that's totally acceptable because, again, we didn't go over the homework from Monday. So whatever you guys have questions on, totally fine. We can get the ball rolling here. Just specify from which homework your number is from. No questions. Nobody has any homework questions. I don't believe this. No way. Okay. All right. Thank you. So 40 from this current homework. Sure. Okay. 40 twice. Fantastic. We're going to do it once. Okay. So for number 40, it says use the factor theorem to show that x plus 3 is a factor of that following polynomial, so that big long polynomial, and then check your answer by synthetic division. Okay. So what I want to do is let's go ahead and write this all out. So first off, we have the big long polynomial, which is x to the fifth plus 3x to the fourth plus x squared plus 8x plus 15. And we're trying to show that x plus 3 is a factor here. So factor theorem says that if we're dividing something, or if we're trying to show that something is a factor of another larger polynomial here, that something has to be in the form of, and I'm just going to write it in red underneath it, x minus a, right? X minus a, this is the form that is built into the factor theorem, into the remainder theorem, and into synthetic division, right? You're always essentially dividing by something that is in the form of x minus a. So to show that something is in fact a factor, essentially what it's asking you to do is, first off, get your x plus 3 in the form of x minus a. So we have x plus something. So if I want to change this to x minus something, I just need to change that plus to a double negative, right? We know that negatives cancel in pairs, so we know that we can change that plus to two minuses. So this is just going to be x minus a negative 3. And that helps us because that tells you now what your a exactly is. Now we see our a is negative 3, as opposed to it being positive 3, like, it was appearing before. The trick here is remembering that everything is in the form of x minus a, okay? So once you've gotten this far, all you have to do now is plug in your a into your higher polynomial, into this long underlined piece here. And assuming you get 0, you have now shown that x plus 3 is a factor. If you get f of a is equal to 0, so f of a is equal to 0, then you know that x minus a is a factor. And that says factor, even if we can't really read it, but that's okay. So the point here is that what we're going to be doing is we're going to be taking that negative 3, and we're going to be plugging that negative 3 into our polynomial here. Okay, so what does that mean? So that means we have f of negative 3 is equal to, and then we start plugging it in wherever there's an x in this big long thing here, right? So there's x to the fifth, which means we have negative 3 to the fifth. Then we have plus 3 and then x to the fourth, so plus 3 times negative 3 to the fourth plus x squared. So we have plus negative 3 squared plus 8 times x. And last but not least, plus 15. Okay, So if you got this far, that's fantastic. That means, you're understanding at least the principle of factor theorem. You're just taking, your x minus a, you're taking that a, whatever that number is, and you're plugging it into your giant polynomial. And that's great. If you didn't know how to simplify this and you didn't have a calculator available to you, let's think about a little bit of a trick here. So I don't really want to figure out what -3 to the 5th is, and everything that I'm about to do you can easily do with a calculator. I just want to show you that a calculator here isn't necessary. Okay, so I don't necessarily want to figure out what -3 to the 5th is, and I'm not going to do any sort of mental manipulation to figure it out. Why I don't need to figure it out is because I know that -3 to the 5th is going to come out to be a negative number, right? So I know because it's a negative number to an odd power, I know the final result is going to be negative. It's kind of like if you had, just for example, if you had -2 cubed, you know that that's -2 times -2 times -2, and you know that negatives cancels in pairs. So because you were because you had an odd power, you know that you're keeping whatever sign that you had, right? So I know that this number gets really big, and it's going to be a negative number, right? So this is the same thing as if I had -3 to the 5th. So all I did is I pulled that negative out because I know that that's going to be the end result anyway. And now if I look at the other piece right here, which I've just underlined, this 3 times -3 to the 4th, well, -3 to the 4th is, okay, well, the negatives are going to totally cancel out. And how do I know that? I know that because this is an even power. So because this is an even power, it's, again, as if you had, this is -3 squared, but we know that negatives cancel in pairs, so you would just have 3 times 3, which is 9, right? So you'd get a positive number back. So we know that we're going to get a positive number back, and so this is essentially the same thing as 3 times 3 to the 4th. But what is 3 here? You have the same base. And when you have the same base being multiplied together, you can just add the exponents. So 3 to the 1st times 3 to the 4th, well, this is the same thing as 3 to the 5th. All we're doing here is just some exponent manipulation just to save ourselves some trouble of plugging these numbers in. And we know that there's addition here. And then you say to yourself, oh, I have a -3 to the 5th plus a positive 3 to the 5th. Well, these are just going to cancel out. And I didn't need to figure out those numbers at all. If you didn't follow me on that, that's okay. I prefer you ask me as, where you got confused here. But, figuring out what -3 to the 5th is and also what -3 to the 4th is, totally acceptable. And, just plugging away and then adding them together. And you'll find out that they do, in fact, cancel out. Okay, so we know that those two numbers cancel out, so we just have to figure out the rest here. So -3 squared, well, we already just talked about this. -3 times a -3, the negatives cancel out because, again, it's an even power. So we know that we get a positive 9 here. Then we have 8 times -3. So 8 times 3 is 24, and we know it's negative, so -24. And we have this positive 15. And when all is said and done, 9 minus 24 is -15 plus 15 gives you 0. So by factor theorem, you have in fact shown that x plus 3 is a factor of the polynomial above. All you're ever trying to do is show that whenever you're plugging in that number, in this case, it's -3, but all you're ever trying to do is when you plug that number into your larger polynomial here, as long as you get a 0 for your remainder, you know that you have shown that this is a factor. Okay, don't get too bogged down in what I did with, the -3 to the 5th and the -3 to the 4th piece. That was just some manipulation because I saw that there was a 3 being multiplied, so that -3 to the 4th, which would essentially make it 3 to the 5th. So, but in any event, does anybody have questions on just the general procedure here? So we started with understanding that it should be in the form of x minus a. So we changed this x plus 3 to an x minus a -3. Again, just change change the appearance of it without changing the value. We always know that we can go backwards, right? X minus a -3 is the same thing as x plus 3. So now that it's in the correct form, we know that -3 is the number we need, and we just plug -3 into our big long function here, wherever there's an x, and as long as we get 0, we have shown that this is in fact a factor. Okay. The no number from lecture 23.
I have a question.
Yes. What's going on?
Like how'd you like you see how it's like it was 3/5 and three to the fifth and 3 to the 4th? How'd you get it like 3 to the 5th and 3 to the 5th again, please?
Yeah, sure. So do you agree with me that if I have 2 times 2, that this is the same thing as 2 squared?
Yeah.
Okay. And we know by exponent rules, the reason that this works out is when you have the same base being multiplied against each other, what you're really doing is you're adding the exponents, right? So we see that we have the same base, 2 and 2, right? So essentially what I did is I just added the exponents together, which is 1 and 1 here, right? Okay, so what I did to make the 3 to the 4th and the 3 here, so I'm just going to circle this piece in red. So to simplify this right here, what I did was I noticed, okay, well, negative 3 to the 4th. The first thing I did was simplify the negative. Negative 3 to the 4th should just give me the same result as 3 to the 4th. And the reason I know that is because, again, negatives cancel in pairs, and this is, an even power. So I know that I'm going to have an even number of negatives, so they should, in fact, all cancel out. Are you with me so far?
Yes.
Okay, great. So we know that we have negative 3 to the 4th is really just 3 to the 4th. But I was multiplying 3 to the 4th by this coefficient of 3 in front of it, right? So if I have 3 times 3 to the 4th, well, once again, all I'm really doing is I'm just adding the exponents together, right? We have the same base being multiplied against the same base. 3 and 3, it's the same base. So I'm just adding the exponents together, and the exponent of the coefficient of 3 is just 1. Right? So when I'm adding the exponents, I just have 1 plus 4, which gives me 3 to the 5th. So that's how I simplified the P circle in red. So I know that I have a positive 3 to the 5th here. So that's this positive 3 to the 5th. And then for the negative side, well, the negative side is very similar to how I reduced the negative 3 to the 4th. Well, if I have a negative 3 to the 5th, that's going to be the same thing as if I had 3 to the 5th, but just a negative on the outside. The reason is because, again, I know that negative 3 to the 5th is always going to give me a negative number, because if I have one negative and I am multiplying it 5 times, right? There's 5 negatives in total. Well, negatives cancel in pairs, right? So I'm going to have, just to really illustrate this, I'll write it all out. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3, right? We know that they cancel in pairs. So 1, 2, 3, 4, and we will always have that one negative left over, right? So I know that my final answer here should be a negative, and I just kept it as 3 to the 5th because I saw that I could simplify the piece circled in red to also be 3 to the 5th. So now you notice that you have negative 3 to the 5th and positive 3 to the 5th, and as long as you have a negative and a positive of the same number, regardless how large that number gets, when you add them together, they should just give you 0, right? They cancel out. Negative 2 and positive 2 give you 0. Negative a billion and positive a billion give you 0 when you add them together.
Thank you.
Yep. Good question. Okay, I'm going to go ahead and erase this, guys. So we're going to move on to 23 from the previous lecture. So this is going back to the one that was supposed to be for Monday. Okay, so the way that what we have first, let me write it out, is we have x squared plus 2x plus 4 all over x plus 1. Okay, so what you were supposed to do with this is you were supposed to do this by factoring. Okay, so you're trying to solve this by factoring. The idea behind this is that whenever you're trying to solve something by factoring, you're always trying to get the same factor in the top as you have in the bottom, right? If you have the same factor in the top as you do in the bottom, then you can cancel them out, and then you've effectively done your division, right? So what do we have in the bottom? We have an x plus 1 in my denominator. So if I can factor the top such that I get an x plus 1 also on top, then I can cross those out, and then I'd be done, right? Then I've done my job here. I've factored, and I've done the division. So my objective here is I want to get an x plus 1 up top. But we ask ourselves, okay, well, does x squared plus 2x plus 4 factor into that? And the answer is no, right? If you try doing this factoring, it's not going to factor nicely. And that's actually what I specifically said, is that in the hint, it's not going to factor nicely. So what you want to try to do is you want to manipulate your final term over here, which I've just circled. So that way you can essentially just factor the x squared plus 2x plus something, and one of those factors should give you an x plus 1. Okay? Where is this coming from? Well, if you look ahead, again, the entire idea is we're trying to get an x plus 1 on top. Remember, x squared plus 2x plus 1, if we had just a plus 1 here, well, how does this factor? This should be, if you look at your factors here, 1, and then you ask yourself, okay, two numbers that add together to give me a 2, that multiply to give you a positive 1. Oh, yeah, well, this is, when I factor it, this is the same thing as x plus 1 and x plus 1, right? And then, yeah, we've done this, right? So if that 4 was a 1 instead, then we can easily factor this, and we can get an x plus 1 on top. In fact, we get two of them, but we only need one of them because we only have one of them on the bottom. So my job right now is I want to change this 4 to be a 1. I want to somehow manipulate the 4 on top so that way I can just have a 1 here, and then I can factor this, and then whatever's left over is left over, right? So what I'm going to do, and I'm just going to erase this real quick just to clean things up. So 2x plus 4. So what I'm going to do is I know at this point I need an x squared plus 2x plus 1. So I'm going to split up that 4. So x squared plus 2x plus 1 plus 3. And we agree here that if you have 1 and 3, and we went backwards, right? 1 plus 3 is in fact 4. So I haven't changed the value of this. I've just changed the appearance. I just split the 4 up into the piece I want and the piece that I don't want. So, and this is still all over x plus 1. And the reason that I did this is because now, if we consider the piece in parentheses, I can factor this. I can look at this piece here and realize, oh yeah, if I factor x squared plus 2x plus 1, I should get, factors of x plus 1 on top. And then, that's going to lead me to be able to simplify with the x plus 1 that's on the bottom. So moving onwards, we are going to do that same factoring. So when I factor this, again, we already just talked about, we should get x plus 1 twice, which is the same thing as x plus 1 squared. And then we just have this plus 3 hanging around, and this is over x plus 1. Now, at this point, if you try to do any sort of cancellations, if you tried to just do that, this is incorrect. And the reason this is incorrect is because you still have this positive 3 also being divided by x plus 1. You can't do the cancellation immediately. So what we have to do is something that we did in the lecture video. We see that, okay, we have some piece here being divided by x plus 1, and also another piece being divided by x plus 1. So I can split these up into two different fractions where the denominator is the same. And what I mean by that is I can take x plus 1 squared over x plus 1 and add it to 3 over x plus 1. I split it into two different fractions where my denominator is the same piece. And the reason this works is because, well, when you're talking about adding fractions together, imagine we were going backwards, going upwards now, up the page. If we had two fractions with common denominators, what would you do? You would combine it into one fraction with one denominator. It would be the same denominator, right? Denominator. And you would just add or subtract the numerators. So in breaking them up, you're just keeping the denominators the same, splitting up the two fractions, and you're taking whatever pieces are being added or subtracted in your numerator and throwing them into their each separate fractions. So I took my 3 and brought it over here, and I took my x plus 1 squared and brought it over here. And I kept the denominators the same because this was starting as one original fraction, right? And again, going backwards, if you have the same denominator, you can always combine your fractions. So great. I split this up. And what was the reason that I split this up? Well, the reason that I split this up is because now I have x plus 1 squared over x plus 1. I have the same factors up top as I do on bottom. So I can cross out one of the x plus 1s on top, and I can cross out the x plus 1 on the bottom, and this leaves me with x plus 1 plus 3 over x plus 1, and we're done. And that's it. And the reason that we know this is it is because, again, we got some lower polynomial, right? We got x to the first power, and then we got, a constant and some remainder, right? We can't do anything else with this, the 3 over x plus 1. That is just the last piece, so we're done here. And to really verify that this makes sense, that I should get an x to the first power, let's think about our leading terms here. So our leading terms are x and x squared, right? So if you had x squared over x, you should just get x to the first power back. So when we're talking about our leading terms here, that also tells you the, how this should end as far as what your highest power should be. And our highest power was, in fact, x to the first power. So yeah, we're in the ballpark here. As long as we did the other steps correct, this is, in fact, the correct answer. So this is it. Again, the hardest part by far is right up here, recognizing how to do this manipulation. Going from the x squared plus 2x plus 4 to splitting it up into the plus 1 and the plus 3, because you know that you would need the plus 1 to do the factoring. That's absolutely the hardest part, and I do not blame you if you didn't see this immediately, but hopefully if you see this now, it makes a little bit more sense. Can you also manipulate it with 4 minus 3 plus 3 at the end? Yes. Yep, because if you have 4 minus 3 and you do that simplification, that's going to give you a plus 1, and then you have that plus 3 stuck out at the end as well. Yep, that's totally acceptable. Again, your entire idea here is that you have this plus 1 remaining, and then you're going to have a remainder of plus 3. So however you arrived at that destination, there's a couple different ways. This, for me, was the easiest because I saw that I already had the plus 1 hiding inside of the positive 4. So I knew I could just split the 4 into a 1 and a 3. But yeah, absolutely. You could take the, You could take the approach of completing the square, in fact, and that might even help you out as well. Because completing the square is doing the same thing that we just did here. Completing the square is considering the first two terms, which I'm just going to circle in red here. So completing the square is considering the first two terms and trying to factor based off of those two terms. So in this case, what is your tool for completing the square? It's b over 2 squared, right? So it's 2 over 2 squared if you were to complete the square, which gives you 1 squared, which gives you 1. And that tells you that you would need to add a positive 1. And so if you added a positive 1 and subtracted a positive 1, and subtracted a 1, you would end up with the same thing that I got here, because the subtraction of 1 would be applied to your already existing 4, and that would give you the remainder of 3. So again, there's a bunch of different ways that you could arrive at this, but the point is that you would get a positive 1 added and a remainder of 3 tacked on at the end. Yeah, no worries, Sophia. It happens. Okay. So again, we did our factoring, we split up the fractions just like we did in the lecture, the lecture that was into Monday, and we arrived at our destination here of x plus 1 plus our remainder of 3 over x plus 1. Okay, so I'm going to go ahead and clear this off, and Keji, 47 on, I imagine, the current lecture, the one that we just did. Okay. So prove that x minus 2 is not a factor of the following polynomial. So let's write out our polynomial. Our polynomial is negative 2x cubed plus 4x squared minus 4x plus 9. Okay, and the divisor here, what we're trying to prove is that x minus 2 is not a factor. So x minus 2. Okay, so let's see. Melissa, if you can help me out, how am I going to set this up? I'm talking about factor theorem here, right? So how do I approach this using factor theorem? Okay. So no Melissa. Let's see. Brooke, are you there? Can you help me out?
Yes. Could you repeat the question, please?
Yeah, sure. So what we're trying to do is we're trying to prove that x minus 2 is not a factor of the above polynomial. So how do I set this up with factor theorem? What's my idea here? How do I use factor theorem?
I'm not exactly 100% sure.
Okay, so what's the form that synthetic division, factor theorem, and remainder theorem all need your divisor to be? It's like x and then some number, right? So what's the sign that's going on between the x and the number?
A positive.
Close. I mean, you gambled, right? So x minus a, right? This is the form that we need it to be in. So luckily for us, we already have a minus sign, right? We have x minus 2. So we know then that our number is just going to be the 2. The negative sign is already built in, right? So we know that for factor theorem, for remainder theorem, and for synthetic division, you need it in the form of x minus a, which this was given to us, that prove that x minus 2 is not a factor. So to prove that x minus 2 is not a factor, we're going to use factor theorem, and then we're going to show that we get a number that's not 0. Remember that the way factor theorem works is that if we plug our number into our larger polynomial and we get a 0 back, we've shown that it is a factor. But if we get any number that's not a 0, then it's not a factor, because that number is indicative of a remainder, right? So this is basically saying, okay, plug in your 2 into your big long polynomial here, see what number you get. If you get any number other than a 0, you have shown that x minus 2 is not a factor. So we have f of 2, and we're plugging in 2 wherever there's an x, right? So we have negative 2 times 2 cubed plus 4 times 2 squared minus 4 times 2 plus 9. All right, let's go ahead and do some simplifications together. 2 cubed gives me 8. Times negative 2 is negative 16. So we have negative 16 here. We have 4 times 2 squared, which is also going to be a positive 16. So we have positive 16 here. Negative 4 times 2 is negative 8. And then we have this plus, what was it, plus 9 or plus 19? That's just a 9. So then we have this plus 9 at the end here. Okay, so negative 16 and positive 16 cross out. And then we just have negative 8 plus 9, which gives us 1, which means when we plugged in our number here, when we plugged in 2 from the form of x minus a, we got a number back that wasn't 0. If we got a 0 back, that's using factor theorem to prove, in fact, that x minus 2 is a factor. But because we got a remainder of 1, we know that x minus 2 is not a factor. That's it. That's the entire idea. So factor theorem is just taking whatever your number is that's being tacked on to your linear polynomial. Linear, again, means first order, right? This is x to the first. So whatever the number that's tacked on to your linear polynomial, you take that number, you plug it into the highest one, and then that's it. If you get a 1 back or any number back that's not a 0, it's not a factor. If you get a 0, then it is a factor. I was getting confused on what number to plug into the polynomial. Do we do the opposite of x minus a? So if you want to just think about it as you're just taking always the opposite sign, that's totally acceptable. So we were given Aline, we were given x minus 2 here. So if you just want to say to yourself, okay, whatever that number is, so this number here is a negative 2, I'm always going to be plugging in the opposite of it. Totally fine way to approach it. I just want you to understand that it's built in, that negative sign is built in, because it's always in the form of x minus a. So, the reason that you're taking the opposite sign isn't because you're doing any sort of negation. It's because, oh yeah, you have a negative here, you have a negative here. So a is really just whatever number follows the negative. So a positive 2 follows the negative. But again, if it just makes more sense for you all to just say, okay, well, it needs to be in the form of x minus a, just always flip the number, the sign of the number, then sure, yeah. So we were given x minus 2, so you're plugging in a positive 2. I made the same mistake for 40 and 47. Yeah, that's why we do this, right? That's why we have these meetings and we go over the homework together, is because, these kind of mistakes I expect you guys to make, so I want to go over this together so that way everybody understands what we're doing. So yeah, that's totally fine. Yep. Okay. Any questions on this, on how to use factor theorem before we get going? or before we move on, again, the idea here is, again, you're just taking in the opposite sign number, whatever your a is, right? You're flipping that sign just like I just talked about with Aline here. So we were given x minus 2, so we're plugging in a positive 2, and we're plugging that positive 2 into the larger polynomial. And as long as you get a 0 back, you have proven that the smaller polynomial is a factor. If you get any number that's not a 0 back, then it is not a factor of the larger polynomial. And I promise it's that simple. Just plug and chug, and then if you get a 0, hooray. If you don't, so be it. Okay, so if there's no more questions with that, I'm going to go over to Keji's other question, which is number 10 from the previous lecture. Okay. All right. Yep, let me go ahead and pull that up.
How was the answer to that one?
I'm sorry, what'd you say, Kenny?
How was the answer to that one?
So, I mean, even if it's not 1, it shouldn't be 0, right? So let's see. We have 2 cubed, which is 8, right? So let's do all of it out. So we have negative 2 times 8 plus 4 times 4 minus 8 plus 9. You agree with this so far, right? All I did is, so 2 cubed is 8, 2 squared is 4, and we're still good to go, right?
Yep.
Okay. And now we have negative 2 times 8, which is negative 16. Positive 4 times a positive 4, which is a positive 16. And then negative 8 plus 9. And then now we have negative 16 and positive 16, which cross out to give me 0. And negative 8 plus 9 is the same thing as 9 minus 8, which should give me 1.
Got it. Thank you.
Yep, you got it. Okay, so let's go ahead and clear this off. And now we're jumping to number 10 from the previous lecture. So number 10 from Monday's homework. So this is x to the 6th plus 5x cubed plus 7x plus 3. And this is all being divided by x squared plus 2. Okay, so we have this following. Let me just really clear this up. Should be a 3. Okay, so we have to solve this using long division. Even if I didn't tell you to solve this using long division, this looks absolutely terrifying to try to factor. I would probably never in a million years try to factor at the top. That sounds miserable. And then you can't use synthetic division. And the reason you can't use synthetic division is, for synthetic division, you need your divisor to be in the form of, just like factor theorem, just like remainder theorem, x minus a, where x is to the first power. What do we have here? We have x squared, right? So we know that we can't use synthetic division. Again, the direction specified to use long division, but this is just letting you know that if this were on a test or a quiz or something, you absolutely could not use synthetic division because it won't work. I know I said during the lecture that there is technically a form of synthetic division that allows you to use powers higher than 1, but it gets really messy, really complicated, and for the purpose of this class, we're not going to learn it here, okay? If you guys do, if you are interested in that, feel free to see me later about it, but for, the purpose of just this question on the homework here, long division. So, how do we set up long division? Well, first we take our divisor, x squared, and so now I'm going to ask you guys, do you guys want the placeholder here for the 0x, or do you not want it? It really depends on, just your ability to put things in the correct columns. If you want to see it, that's fine. If not, we can ignore it. Yeah? Okay, sure. So we'll put the placeholder of the 0x plus 2, so that's out of the box. And the 0x, where this is coming from, is it's my placeholder, because notice in my divisor, I have no x's, right? So we're just going to go ahead and put that in there. And now we have to do the same thing for the piece that's being divided, right? We always have to put placeholders for the thing that's being divided. So we have x to the 6th, and now we have no 5th, and we have no x to the 4th, right? So we need placeholders for those. So plus 0x to the 5th, plus 0x to the 4th. Then we have plus 5x cubed. We don't have a square, so we have to put another placeholder. So we put plus 0x squared plus 7x plus 3. Okay. As you guys can see, long division gets very, very long. So whenever you have the opportunity to use synthetic division, I generally recommend it. In this case, we didn't have the opportunity, but that's okay. Okay, so I'm going to ask for literally anybody to help me out here. What is my step here? What do I do when I'm trying to do long division? I need to, have a first step. So we wrote it out. We have it in the form that we need to get it to. That's great. Now what do I do? Yes, Zanita.
We have to match the x squared to that first term x to the 6 by multiplying it by x to the third.
Okay, you were 99% right. The last little piece that you got caught up on is that x to the third. We just talked about multiplying numbers when they have the same base. What do we do with the exponents? If I have x squared times x to the third, what happens to the exponents?
You add them,
Yeah, so this would be x to the fifth, right? So just make that small adjustment for me. What do I actually need to multiply by?
X to the fourth.
Perfect, x to the fourth, right? So we have x squared. We know that when we multiply it by x to the fourth, we get x to the sixth, right? So perfect, thank you, Zanita. So we know we're going to multiply by x to the fourth. And then now what we do is, because we figured out we need to multiply by x to the fourth, we take our x to the fourth and we multiply it against the entire divisor, right? So when we multiply it against the entire divisor, we get x to the sixth, then x to the fourth times 0x is the same thing as 0x to the fifth, right? This is x to the first power. So when you do that multiplication, that's, you add the exponents. So we have 0x to the fifth, and then you have x to the fourth times a positive 2. So this should give you plus 2x to the fourth. And remember, you're subtracting the whole thing, right? So you're going to be negating all of these signs. So x to the sixth minus x to the sixth, those are just going to cancel out. We can put a little red line through them, and they cancel out by the process that we just did, right? Every single time you're doing long division for polynomials, you should always be essentially canceling out that leading term. So every time your leading term should be canceling out, and that's just by, figuring out what we're multiplying by. So in this case, x to the fourth. Okay, so that cancels out. Then you have 0x to the fifth minus 0x to the fifth. So this entire column also cancels out. You're done here. There is nothing to be done. So having that placeholder here might help you out. I also just want to point out that if you didn't put the placeholder here, all you have to remember to do is when you multiplied the 2 and the x to the fourth, you just needed to make sure that you put it in the correct column, which I'm just going to box right here. Okay, if you put that 2x to the fourth in the x to the fifth column, then you would have problems. But as long as you remember to put it in the correct column, you don't need that placeholder of 0x to the fifth for your divisor. Okay, but in any event, we're doing this. We have it, so that's okay. So we're going to go ahead and do the subtraction. So we have 0x to the fourth minus 2x to the fourth. So we have negative 2x to the fourth, and we're going to go ahead and bring down some pieces, right? So bringing down some pieces, now we have plus 5x cubed and plus 0x squared. Why did I bring down 3 terms? Or, well, I technically brought down 2 terms, but why do I have 3 terms now? The reason that I have 3 terms total is because I know I'm dividing by 3 terms. So that I know that 3 columns are going to be impacted here. Okay, so let's go ahead and do the next thing. Let's see. So Zanita, help me out. Taylor, can you help me out? I want to figure out what I need to multiply by to give me this negative 2x to the fourth. Kayla, if you can help me out. What I want to do is I want to find this negative 2x to the fourth, right? And I know that I need to multiply my leading highest power by something to get there. What do I multiply by?
You may have to multiply x squared to the negative 2x to the fourth. Is that?
Yeah, so basically I'm trying to get my x squared to be negative 2x to the fourth. What do I need to multiply x squared by to give me that number? So break it up in pieces. What's the coefficient of x squared right now? Just, the coefficient of my divisor.
1.
Yeah, okay. And then how do I get 1 to become a negative 2?
Just 1 times negative 2.
Great. So we know that we're going to need a negative 2 right here, right? Because to get 1 to -2, we know we need to multiply by -2. Okay, cool. So you're almost done. How do I get x squared to give me x to the 4th? What do I need to multiply by?
It was a negative 2x to the square times. Oh no.
So I have x squared, and I want to get to x to the 4th. So I know I'm going to need to multiply by x to some power right here. I just need to figure out what that power is. Now remember, we add exponents together, right? So 2 plus something should give me 4. What should that number be?
2.
2, perfect. So that means I need to multiply by -2x squared. If I multiply by -2x squared, then my leading term is going to give me -2x to the 4th. Perfect.
Thank you.
Yeah, thank you. So x squared, I'm just putting that back there. Okay, so now I take my -2x squared and I multiply it by the entire divisor again, right? So we get -2x to the 4th, which is exactly what we wanted. Then -2x squared times the middle term. Well, once again, that middle term is always going to give you 0, and it's just going to, the degree is going to vary here, right? So it's in this column. We know that it's going to be minus 0x cubed, and you can make it minus or plus, it doesn't matter. I'll keep it plus because it's 0, it won't matter either way. So plus the 0x cubed, and then -2x squared times a positive 2, well, that should give you a -4x squared. So minus 4x squared. And now, again, the caveat is you're always subtracting here with long division, so all of these signs are going to flip. So that means that when you have -2x to the 4th minus a -2x to the 4th, these should cancel, right? It becomes addition now. So these pieces cancel out. Then you have 5x cubed minus 0x to the 3rd. So, well, 5x cubed, this just drops down. So 5x cubed, nothing's happening here. And then you have 0x squared plus 4x squared, right? Minus a -4x squared makes it plus. So plus 4x squared. Okay, so we got rid of that leading term, -2x to the 4th. That's how you know you're making progress. We pull down our next term, which in this case is 7x. So pulling down the next term, we have plus 7x here. And now we play the same game all over again, right? I need to multiply by something to give me 5x to the 3rd. In the interest of time here, just to make sure that we get through this, I'm just going to go a little bit faster here. So x squared to give me 5x cubed, I know I need to multiply by 5, and I also know I need to multiply by x, right? X squared times x gives me x cubed. So that means I'm going to be multiplying by 5x. So plus 5x. So when I do this, I get 5x cubed. And then 5x times my middle piece here, the 0x. Well, once again, that's just going to be 0x squared. So 0x squared. And then 5x times 2 is a 10x. So plus 10x. I subtract the whole thing. Subtracting the whole thing, the 5x cubes cancel out. 4x squared minus 0x squared is still just 4x squared. So this column remains untouched. And then we have 7x minus 10x, which is -3x, or minus 3x. Okay, we're almost done. We just have to bring down the last piece here, which is the plus 3. So bringing down the plus 3, we try this one more time here. So I have x squared. I need to get 4x squared. So I'm really just worrying about the coefficients here, right? I need to get from 1 to 4, so I multiply by 4. So plus 4 here, right? So multiplying by 4, we get 4x squared. 4 times the 0x gives me, again, 0x. And then 4 times, what was the number? Positive 2 gives me a positive 8. And when I do this subtraction, well, 4x squareds are going to cancel. I have -3x, which doesn't do anything, right? -3x just stays -3x. And then we just have the positive 3 minus 8, which is -5. And now you ask yourself, is there anything else that we can do here? And the answer is no. The reason you know it's no is because you have an x to the 1st power here, and you're dividing by x squared. Your power is now less than your divisor. You're done. You stop here. There's nothing else that you can do. You can't do any further division. So you just write out the answers that you got up top. So we had x to the 4th minus 2x to the something, 2x squared. And then the last pieces were plus 5x plus 4. and then we had this as our remainder, right? The circled piece is our remainder. So minus, and technically I'm pulling the negative out of both the 3x and the 5 at the same time. I'm factoring out that negative sign. So now I have 3x plus 5 up top over my original divisor, which is x squared plus 2. And this would be your final answer, which I will box in green. Okay, so the idea here is the idea that you do with all long division, right? You start with your leading terms, just like Zenita helped us with, right? You look at your leading terms. We have x to the 6th, we have x squared. You figure out what you need to multiply your leading term to get to x to the 6th. And then once you figure that out, we figured it out, it was x to the 4th, you take x to the 4th and multiply it against your entire divisor. And then you do your subtraction, and then it's just rinse and repeat, right? You keep doing it until you can't do it anymore, and you end up with some answer, which in this case was x to the 4th minus 2x squared plus 5x plus 4. And whatever is left over, in this case, we had a linear left over, right? Negative 3x minus 5. Whatever is left over, you just throw it over the x squared plus 2 and call it good. And for the record, I know I factored out this negative, so if it's a little bit confusing why I factored out the negative, you could also write this as, sorry, I'm trying to get the black pen here. There we go. You could also write this as a plus and then just keep the negatives where they are. So plus negative 3x minus 5 over x squared plus 2. This is how I would imagine most of you would write this, so that's totally acceptable as well. I just want to point out that you can factor out the negative from the top and have that in front. But either way, this is your final answer. Does anybody have any questions on this? Long division can take a while as the powers get, super large. So I wanted to include one where, it was x to the 6th, but I didn't give you that many homework questions, so hopefully that counterbalanced it. So any questions on this?
I have a question, actually.
Sure. I
So
don't know who's talking. Sorry. Oh,
It's
Gianna.
from Gianna. Sorry. I can't really see your screen right now, so I'm kind of just gonna listen to what you're saying. But for question 12, for an answer the remainder, it's a positive 15y minus 22.
Mhm.
So how would you write the remainder next to your answer with the positive 15y?
Well, it's always, so it's plus and then whatever you have up top, right? So I know you said you can't see my screen for whatever reason. Our remainder in this case was a negative 3x minus 5, right?
Mhm.
Hopefully you got that. So if you had a negative 3x minus 5, you can just throw that over your divisor and stick a plus in front of it because
Okay.
your negative signs are already part of that numerator, right? So you don't have to worry about any sort of factoring. So in the case of question 12, you said it was 15y minus 22. Is that what you said?
Yeah.
Okay, so for y, you get a remainder of 15y minus 22. So you would just write it as 15y minus 22 over your original divisor, which is y squared plus 2y minus 3.
Mm-hmm.
Yeah, sounds about right. So you would just have it like that. So, and then you would have a plus sign in front of it because you're adding that fraction.
Perfect. Thank you so much.
Yep, you're welcome. Any other questions, guys? Okay, it's 11:48. I'm going to give you guys back 2 minutes of your lives. If you needed to talk to me after class, stick around. I'm going to end the recording right now. And yeah, if you don't need to talk to me, then, oh, wait, guys, sorry, one last thing. I'm so bad at this.